First question from Robert. Does the via fill material affect the reliability? Well, in short, the answer is yes, it can affect the reliability. One of the major ways that via fill materials affect the reliability is due to their thermal expansion. So if there is a large thermal expansion mismatch compared to copper along the z-axis, then you basically get the same effect as with a large mismatch with respect to the PCB material. The PCB material expansion in the z direction can be quite large for FR4 grade materials, and you like to minimize that as much as possible. And this is one of the reasons that many of the newer HDI buildup films and ultra HDI materials have much lower CTE values in the z-axis. It is to get a closer match to the thermal expansion coefficient for copper. Same applies for the via fill material. We want to make sure that that via fill material does not put any pressure on the cap plating on the top and bottom of that via and then create any kind of cracking during expansion events. Robert's follow-on question is also, what about through via filling and capping versus micro vias? Well, comparing through-hole vias and micro vias is a bit like comparing apples and oranges. With micro vias, the vias on the outer layer can get filled in completely with copper and then plated over to form a planar surface for soldering, especially when you're doing small diameter vias in pad on fine pitch BGAs. So when thermal expansion occurs, you have the entire via expanding and contracting at the same rate, so you don't have this thermal mismatch problem inside the via like you would in a through-hole via that's filled with a resin. With micro vias, the most common place to see a fracture is at the via ball interface or at the via interface when you have stacked micro vias. Next follow-on question from Robert. Also, does this apply to larger pitch BGAs, since you might be forced to use via in pad there too if you are space constrained and or you are not allowed to use micro vias for different reasons? Yes, it absolutely does apply to larger pitch BGAs that use via in pad. Although, of course, one of the benefits of using a larger pitch BGA is that you can try to avoid via in pad and hopefully have higher reliability by placing the via outside of the pad. Now, there are some cases relating to signal integrity where it is beneficial to put the via in the pad even though you don't need to, simply based on space constraints. I show some examples in some of my seminars relating to BGAs on components that have 56G interfaces or 112G interfaces. There, you're bringing differential pairs directly into the pad so that you avoid having those small transmission lines between the bottom of the ball on the BGA package and the top pad on those vias.